Good morning, good afternoon, and good evening, everyone. Thank you for joining us today for our webinar about LoRA Exchange, how to serve hundreds of fine-tuned LLMs for the cost of serving one. Super excited to have everyone. We have some polling questions that we'll start to push out. And as we wait for folks to join, you can start, just answer those, learn about sort of what people are up to. And you also see the results. You can see what some of your peers are doing. And we'll get started in just a minute here. We have a good crowd. And I'll mention today, we will have the lines will all be muted, but you can ask your questions, and we encourage you to ask your questions in the chat on the sidebar there. And we will both answer them in chat as well as do a live Q&A at the end. So if you have some burning questions, please make sure to put them in the chat. And we'll take some of our poll questions while we wait for folks. Give another minute here. See, we have folks dialing in from around the world, which is super exciting. All right, we have about 150 people in the room already and growing, so I'm just going to kick it off. Thanks again for joining us. As a reminder, as I mentioned earlier, all lines are muted, but please add your questions to the chat sidebar there. We will answer them both in the chat window and also live at the end. If you'd like to use Predibase for free, we offer a 2-week free trial where you can train or fine-tune and serve Llama 2 and a number of other open source models as many times as you want. All you have to do is fill out a short form, and so there's a link there, and we'll share that in chat as well. And if you're interested in learning more about our open source Ludwig project, you can join the community at ludwig.ai. And people typically ask as well, will the session be shared afterwards? Absolutely, we record it, and it will be sent to all people who registered. With that, I'd like to hand it off or introduce our speakers today. We have Travis O'Dare, who's one of our co-founders and CTO over here at Predibase. Has a long history of building out distributed ML training infrastructure, where he was part of the Michelangelo team at Uber. And also Dev Rishi, who is our co-founder and CEO, who also has a deep background in machine learning, deep learning, was a first PM at Kaggle, also worked for Google on a number of really cool projects. All right, so I'm going to hand it over to Travis to kick things off.
All right, thanks, Michael. All right. Okay, so welcome everyone. Just to kick things off, I want to set the stage a bit by talking about the reason why we're all here, which is this LLM wave that's been sweeping the world for the past year or so now, since the release of ChatGPT about this time last year. And one thing that I think is useful when setting the stage is to think about the fact that when you look at this trend line over time of going from these small tabular models like XGBoost to the kind of deep learning boom with AlexNet and BERT from the Transformers work, all the way to today, you can very easily draw the conclusion that like these large models that have these seemingly emergent properties, that bigger and bigger models has been the thing that's been driving the progress and is the thing that's giving you these new generative AI capabilities. But I think the story of a model like Llama 2 there that you see in the 70 billion parameter side is this realization that actually bigger models don't always translate to better models for your particular task. And like one refrain that we like to repeat here at Predibase is that general intelligence is great, but I don't need a point of sale system to be able to recite French poetry. And by that, what we mean is, at the end of the day, if the model is capable of doing all these really general purpose things, you're going to be paying for that in some sense, whether that's in performance on your particular task or latency, reduced throughput, et cetera. There is some cost to working with these very large models, as we'll see. And so the way that we like to think about it is, these commercial general purpose LLMs are still very powerful and very worthwhile and as part of an LLM story for an organization. And I think the way that they've really changed the game has been in changing the way we think about data science from first principles. Instead of thinking about starting from scratch and collecting lots of data to be able to train a model that can maybe do the tasks that you're looking to do, these big general purpose models are really fascinating because you can start prompting them without giving it any training data, maybe just a handful of examples, and you can get going very quickly and put something like a prototype into production even. But while they're great for building these prototypes and getting started, as you start to scale up your system, as you start to send it more queries over time, you quickly realize that they're actually quite expensive, quite slow, and overkill for most tasks, and have a couple of other properties that are undesirable for a lot of organizations, like you need to give up access to your data in order to use them because they're an API. And you don't really own them all in the IP, so you can't, just take it to another serving provider, et cetera, to get to reduce your costs. Like, you're really locked in some meaningful sense. So we actually see the future of generative AI being starting with these LLMs and then finding the specific tasks that you're trying to perform with them, and then building much smaller, performant, task-specific models for each of these things. And ultimately, what you want is a model that's just big enough for the problem that you're trying to solve, right? So maybe use Mistral 7 billion for doing support ticket automation, chatbot with Llama 70 billion, and even smaller models like BERT for some classification tasks. Using the right model for the right job is ultimately where the long-term value is going to come from as you start to see these things being used in real production scenarios. And there's a lot of data to back this up as well. So we found that, from our own internal testing as well as from others' testing, that fine-tuned models routinely outperform larger models, larger, more expensive commercial models when fine-tuned to a particular task. So here we have some data that we collected ourselves doing some benchmarking, comparing. You can see GPT-4 there, that achieved 66% accuracy on this task versus a fine-tuned 7 billion parameter model that's multiple orders of magnitude smaller, achieved much better performance after fine-tuning. And if you really care about performance, you can see that larger models do give you even bigger performance gains, but those gains are relatively marginal compared to the lift of just doing the fine-tuning in the first place with a smaller model. So ultimately, what a lot of people realize is that productionizing LLMs is harder than it seems. Tools are complex. You need to stitch together lots of open source tools and continually keep up to date with best practices. Fine-tuning is unreliable. If you rent a GPU, you're frequently going to run into out-of-memory errors or other sorts of errors related to not utilizing the resources entirely efficiently. And model serving is expensive, which is going to be the key focus of this particular talk, which is that getting a system that meets SLAs and scales efficiently as you train more and more task-specific models is a real challenge, as we'll see. And so with Predibase, our goal is to fundamentally build a platform that solves these three problems for people looking to put generative AI into production on their data. We want to empower people with simple abstractions that incorporate the latest in AI research into the product. We want to make fine-tuning as efficient as possible so that we automatically right-size the compute that's needed. We have out-of-the-box fault tolerance, and we can run on cheap and commodity GPUs when available. And we want to make serving cost-effective so that you only pay for what you use. You can use an unlimited number of fine-tuned models without having to pay anything extra, and ultimately drive the cost down to be orders of magnitude cheaper than what you get with commercial alternatives or even with dedicated endpoints that you might serve yourself. And our SDK is very simple to get started with. If you're wanting to deploy a model, you can just select your favorite open source model, deploy it. Our platform and our SaaS free trial and consumption-based version of the product comes with several large language models already pre-deployed for you to play around with. Then you can fine-tune a model on your particular data set. This can be any kind of tabular data set with some input columns, some output columns, and that's all you need to get started. And then once you have your fine-tuned model, you can start prompting it in milliseconds thanks to LoRAX, where you just say your original LLM.with adapter, your fine-tuned model, and then you can start prompting it. And like I said, this can get you going as quickly as about 200 milliseconds or so to load it in. So the Predibase platform bundles all of this experience together so that you can very easily connect to open source models and your proprietary data. You can easily fine-tune and customize models using the same open source Ludwig framework that we maintain in the Linux Foundation, and then track your history with our model repositories in the product, and then finally deploy them with auto-scaling and with the power of LoRAX that lets you bundle multiple fine-tuned LLMs together. And all of this is built on top of serverless ML infrastructure, built on top of open source technologies like Kubernetes, Ray, et cetera. And now let's get into the meat of LoRAX itself and this idea of training multiple fine-tuned models. And before I do, one last thing I want to say is a little word on when this would be practical. Like, why would you want to be fine-tuning so many large language models? And obviously, if you're an AI platform supporting many customers like Predibase, that's one reason. That was our main motivation initially for investing in this. But other companies like Uber that maintain their own internal ML platform teams would have similar challenges that would motivate something like this. Another use case we see commonly from customers is segmented models, where you have one task, but you want to build a custom model for different cohorts, like maybe different users. Every user gets their own model, every product, every region, etc. And finally, agents and workflows, so where you want to have a specialized model per task or per step or per action. So examples here would be building out a customer service automation system, where you might have individualized models for classifying intent, figuring out the remediation, generating the response email to the customer, etc. So in practice, I think what folks will find is that there will be many, many models that they'll be wanting to train once they start getting going with this technology. But how much is this going to cost? And this is really the crux of the motivation for something like LoRaX, is that you obviously have lots of GPU options available to you in the cloud. Here's a breakdown of AWS's offerings, for example. Commonly, we see folks using the A10G to serve 7 billion parameter models, because a 7 billion parameter model, 14 gigabytes in memory, 24 gigabytes of VRAM allows you to fit the model, plus have a fairly large batch size. And so it's a pretty good starting point. But this instance type, the G5 2X large, runs about $1.21 US dollars per hour in order to maintain as a dedicated deployment. And so what you see is that this very quickly adds up if you're running this deployment 24 hours a day. So even with just one fine-tuned model, you're paying about $870 per month for this instance. But as you scale up and up and up, once you hit 16 fine-tuned models, you're already over $10,000 a month for serving these things, and it only gets worse from there. So now let's talk about how we can solve this problem. And the main motivation for this is starting with something that we call parameter efficient fine-tuning. So in normal fine-tuning for large language models, you have your data set, you have a pre-trained model, and you're going to update all of the 7 billion or however many parameters in each step. And this is very expensive from a memory perspective, and it's also very expensive from a checkpoint perspective, because you have these very large checkpoints that you're creating. But there's an alternative called parameter efficient fine-tuning that exists that essentially says, instead of adjusting all of the weights of the model, I'm just going to adjust a very small percentage of the weights that I have introduced as new weights and fine-tune those. And so the result is that the fine-tuned model artifact, or what we call an adapter, is very small, usually on the order of about 1% or so of the original model parameters. And one of the most popular parameter efficient fine-tuning techniques out there is one called low rank adaptation, or LoRA. And in this technique, we basically introduce two new tensors alongside certain layers in the original model. And each of these tensors is very small. But when you multiply them out, they have the same shape as the original tensor. And so you can just kind of add the outputs together when you're computing the final prediction. And so it's very easy to serve this in production alongside the original model. All you need to do is load in these weights and then basically compute the outputs on the same input for each of them and sum them up. So how does this look in production when you actually go and deploy it? So in a typical model deployment, you're going to have some Kubernetes pod, if you're running on Kubernetes, that is the kind of physical container for the model. You're going to have some kind of queue that allows you to accept incoming requests from users. And you're going to have the model weights. And then you're going to have these adapter weights that are loaded alongside it that represent just a small fraction of the total parameters. But as you go and deploy more of these models, you're going to end up spinning up a dedicated deployment for each. But one of the things you'll notice is that the parameters between the blue one here and the red one here are actually very similar. The only difference is these small adapter weights. The vast majority of the parameters that are occupying GPU memory are identical. And so that brings us to the first key idea behind LoRAX, which is the ability to efficiently deploy multiple LLMs into the same deployment. So instead of loading each of these adapter weights separately, we're going to load them all together and then maintain separate request queues for each of these adapters that can be managed intelligently with a smart scheduling system. And so in the Predibase API, that looks something like this, my LLM with adapter and then prompt it. Now, we did say that this can support hundreds of LLMs, and so it's quite possible that at some point you're going to run out of GPU memory if you just try to pack them all onto a single device. And so that's where we come to the second key innovation of LoRaX, which is the multi-tiered adapter cache. So what we do is we actually maintain 3 different tiers for adapters at any given time. First, we have the active tier, which resides on GPU memory, and these are the adapters that are currently being accepted and batched into requests that are then sent through for inference. And then below that, we have what we call the pending tier, which lives in host memory, which are adapters that are waiting their turn essentially to become active so that they can start processing requests. And then finally, we have the idle tier, which lives on the ephemeral disk of the pod. And this is the tier that has typically no requests, but did have some requests in the past. And so we at least keep the weights cached on disk in case new requests come in the future. And the nice thing about our implementation is that we're able to preload and offload these weights in the background so that as you're processing requests and a new request for a new adapter comes in, we load it asynchronously in the background, and so it doesn't block the system in any way, and the throughput is not affected by loading in these new adapters. The final innovation that LoRaX brings is what we call continuous multi-adapter batching. And so one of the most important techniques when getting good throughput for large language model inference is a technique called continuous batching, where you essentially allow requests within the batch to be swapped in and out during the decoding process. So as certain requests complete their decoding process and are ready to be returned to the original user, we can take that slot and then add in a new request kind of in flight without having to wait for all the requests in the batch to finish. So this is one of the main drivers of throughput in LLM inference. And so it was very critical that we found a way to get this to work with multiple fine-tuned adapters as well. And so the way we ultimately did it, and you can see here we have different adapters that all fit together into the same batch, is we allow the system to run multiple adapters for the input batch simultaneously. And then we apply a very simple masking operation afterwards that zeroes out the contribution of adapters that don't apply to certain rows in the batch, and then sum the result together and send it through to the next layer. And the result is that even though we applied multiple adapters to the batch, the contribution that comes into the final output is the contribution of only the adapter that applies to each row in the batch. And the next question you might ask is, okay, so how does this work in practice? Does it actually scale effectively? And I think it's a tough question to answer because it's really hard to compare apples to apples performance of something like LoRaX versus just having a dedicated deployment. Obviously, having a dedicated deployment from a throughput or latency standpoint is always going to be more performant. But the question is that trade-off worth it? Is it worth making that trade-off? And so, there's no one-size-fits-all answer to that. But one way we definitely think about it is we say, well, okay, from a pure kind of cost ROI perspective, I would at least want to make sure that as I add twice as many adapters, that I'm not degrading my throughput by 50%, because if I'm by more than 50%, because if I am, then that means that, purely from a how long is it going to take, how long do I have to run a GPU to generate this output standpoint, you'd probably be better off just using a dedicated deployment. And the good news is LoRaX very clearly beats that bar by some significant margin. At a few adapters, we see degradation throughput of only around 10% or so. And then even at the far extreme of packing 128 adapters onto a single GPU. And I should point out that this is under extreme conditions, right? Like when we're throwing as many requests for all the adapters at once at a time, which is probably not something you're going to see in the wild very often. Even in that extreme case, we still only see degradation of about 30% as we double the number of adapters. And that trend continues for some ways as well. So ultimately, we think that the throughput performance of something like LoRaX is actually very, very effective on a cost basis. It's a very similar story for latency. So we scale ultimately sublinearly with latency. As you see, we're doubling the number of adapters here, but we're not quite getting that level of increase in latency. And in general, we're seeing that even at 128 adapters, again with like maximum load on the system, we're still well below a 1 second per token latency. And of course, at small numbers of adapters, we're much, orders of magnitude below that. And one last point to comment on here is that LoRaX, of course, also fits into the broader Predibase platform. And so this is a brief look at kind of our architecture for how things work. We have our workflows for fine-tuning models that write out the weights to object storage. LoRaX can then load those weights dynamically from object storage inside our pods. And we have this split control plane data plane architecture that allows us to deploy this whole thing either in our managed SaaS environment or in a customer's virtual private cloud if privacy and security are of importance for their use case. And so LoRaX as well, we have two different ways that people can think about using LoRaX. One is our multi-tenant SaaS version, where you see you have two different tenants here, and maybe tenant one has two different fine-tuned models that they're using, are all running on the same deployment, which is going to be a lot cheaper per request, but is also going to have potentially a less reliable or less consistent service level agreement. Whereas, we can also allow users to deploy LoRaX in their VPC, which, you still get the benefits of something like LoRaX if you're fine-tuning multiple models, as this user here is, but you don't have to worry about the noisy neighbor problem of someone else's request potentially degrading the performance of your deployment. And so depending on your throughput and latency requirements versus your cost sensitivity, Predibase provides multiple options to kind of find the right deployment solution that works for you. And kind of wrapping up this side of the story, if you look at the cost of running LoRaX, you can see that the cost per million tokens generated is very competitive, both with commercial offerings like OpenAI's GPT 3.5 Turbo, as well as with the cost of running a dedicated deployment, even if you're running LoRaX in VPC. And so what you can see is that in our SaaS environment, we charge a very flat rate, which is about 20 cents per million tokens, regardless of how many fine-tuned models you're training. So even at 32, 128, et cetera models, you're paying that same rate. If you deploy in your VPC, it's going to cost a little bit more because you are renting that GPU, but the amount of time that you need to rent it for to generate 1 million tokens is quite low. And so you see even at 32 fine-tuned adapters, you're paying just about $1 for 1 million tokens versus doing a dedicated deployment where you're paying about $10 for those tokens because you have to use 32 different deployments. And GPT 3.5 Turbo also charges a flat rate, but it's order of magnitude higher than what a platform like Predibase charges. And as such, it takes you quite a bit to reach that limit even with a dedicated compute. But LoRaX is well below that, either in SaaS or in VPC. And so just wrapping up, our philosophy is don't do dedicated deployments per adapter, use LoRA Exchange, and come try it out in Predibase, where our free 14-day trial makes this something you can start getting started with today. And with that, I'll go ahead and hand it over to Dev to walk us through a demo of LoRaX in action on the Predibase platform.
Yeah, thank you very much, Travis, and really enjoyed kind of the benchmarking results we were able to share kind of within with the community. I see a lot of folks that were asking for just access to this afterwards as well, so we'll definitely be sharing out some of the video. What I wanted to do was show a little bit now of how what you saw Travis described can work in action when we're actually looking at being able to use and fine-tune LLMs and serve fine-tuned LLMs inside of your own environment. So here I'm going to be showing you the Predibase platform, how you can use it to be able to fine-tune LLMs very easily, and what it looks like to be able to serve with LoRAX for very efficient model deployments. You can follow along on this actually with me for free. You can sign up for a free trial. It goes for a few weeks, and we've also included a link to the notebook that I'll be walking through that'll actually have the commands for both training and querying these models. When you sign up for the Predibase free trial, you'll be put into our home screen. One of the first things I want to note about our home screen is you can actually both fine-tune Llama 2 7 billion or even Llama 2 13 billion, and we have a quick start on how you can get started with that. Or you can train a smaller supervised machine learning model as well. As Travis mentioned, one of the key things that we believe in is being able to right-size the right model for your task and make sure you're doing the thing that makes the most sense for your particular business. Now, today, I'm going to show you a little bit of what it looks like to be able to fine-tune an LLM to be able to do a very specific task, which is in customer support automation. And I want to be able to walk through what our data set is going to look like, and then I'll walk through how we actually fine-tune and serve those individual models. So here we have a specific task that we're going to call customer support automation. And what we actually have is 3 different types of customers. We have, a customer that gets a lot of customer support tickets about payments and payment settings. Another customer that gets a lot of questions about orders and shipping and arrival dates. And then finally, a last customer that gets a lot of incoming requests about account management and other items like this. So let me show you a little bit of what I mean by kind of the differences in these customers' data. So here you can see that this particular customer, which we call the Order Express, has lots of queries that have to do with maybe order cancellations or being able to understand that they can't afford and given an order. This is an individual customer data set that has a number of different user intents, so chats that have been coming in through customer support channels, and then a customer service automation agent that is looking to be able to respond to those intents, taking into account individual customer specific data like the online company portal, online order interaction, and so forth. Now, this matches one of the use cases that Travis was mentioning makes sense for a system like LoRAX, which is where you have different customers with different types of data, and you want to be able to fine-tune multiple different models. This one for things that will be able to handle things like order cancellation flows. Another customer might have data that looks really at more about like invoices and wanting to be able to check bills rather than shipping and other logistics here. And we have kind of a final customer that's looking at being able to do things again that's a lot more around account management and other things along those lines. And so what we have is 3 different data sets representing 3 different customers that all are in the broader task of being able to do customer support automation. And what I want to walk you through is how easy it can be to fine-tune individual Llama models to be able to solve and customize to each of these individual customer tasks, and then be able to serve those models highly efficiently. So one thing I'll note is you can actually do everything that I'm going to show you through a notebook, also in our UI, including building and training your own custom models. So if you wanted to be able to train a model directly inside of our platform and be able to get access to, for example, fine-tuning a model like Llama 2 13 billion, you can actually do it directly through our UI, which will walk you through a series of options and configurations. But let me show you what it looks like through code, because I know a lot of the folks here are in the engineering audience, and we see a lot of our serious users also look for programmatic access towards our platform as a way to be able to do this at scale. So the first thing I'll do inside of this Predibase demo, and again, this notebook is linked for public consumption if anyone wants to follow along, is I'll just install Predibase and our datasets library. Once I've done that, I can authenticate into the Predibase system just by using my API token, and I can get started. The very first thing that you do in Predibase when you get on the platform is you connect data. In this case, I'm going to just simply create the dataset from the customer support dataset that I had previously. Once I have my dataset connected in Predibase, you'll be able to see it again in the initial data tab that we had just seen. and you'll get access to things like data visualization and general metrics. Each of the data sets that we're fine-tuning our llama models on today are fine-tuned on about 1,000 rows of data, which is empirically where we see the performance of models like Llama 2 and Llama 13 billion start to shine. Now, if I wanted to go back to my code, I've connected my data set and I can get into the next main task, which is I want to fine-tune a Llama 2 7 billion model per customer. What I'm initially going to do is just load in the model that I want to be able to fine-tune. Now, we support fine-tuning many different models. Some of the ones that are on our golden path include Llama 2, 7, 13, and even in our paid offering, 70 billion, as well as the different variants of Mistral. But you can try out many different variants of Hugging Face models directly by passing in the Hugging Face path in this step. Once you've specified your LLM, you'll give it an instruction template response. This is going to be the task that you want the LLM to be able to perform particularly well on. In this case, our template response is going to say, you're a support agent for a company and you're receiving requests from customers. Your job is to respond and provide an appropriate response to the customer. And what we'll send it is the instruction, AKA the thing or the text that the customer is sending and looking for a response from the customer support channel back from. With this same prompt template, we're going to kick off 3 fine-tuning jobs, one for each of our customers: Cashback to the Future, Order Express, and License to Binge. You'll note that all we're doing for each is just passing a single command, llm.finetune. This command is really powerful because it does 2 things. It packages in all of our best practices about model fine-tuning, when to use quantization and what level of quantization to use, how to use lower rank adaptation in the most efficient way possible. And it also will right-size the underlying compute to make sure that these models run as efficiently as possible on the underlying GPUs that they're trained on. In this particular case, we're going to kick off these 3 model training jobs, and each of them will kick off a model repository with a model version page inside of Predibase. I can click into any model version page to be able to see what the model metrics and others look like and kind of track the progress of my training job as it goes. If I click into the training timeline, I can see how long this specific model took to train. And I can see that this model queued for a handful of minutes while we were looking to get the access to the GPUs it wanted to get. Spent about 17 seconds in data pre-processing, and then trained for about 55 minutes before it was ready for production. I can look under the hood to see what compute and which GPU we decided to actually right-size for this particular task. In this case, we decided to use a single G4 instance, which was sufficient, a single T4 instance, which was sufficient to be able to actually fine-tune this model. And then if I'm ready and this model is fine-tuned, I also get access to all of the different metrics to be able to do some offline analysis on whether or not this model's loss and other metrics are looking at the right rate. So I'll get access to the conventional machine learning metrics like loss, but also things that are more specific to LLMs and generative tasks, like character error rate, perplexity, precision, recall, BLEU score, and much more. So you'll get access to all of these metrics, and that will automatically split these up into training and test set, so you can evaluate numerically how well your LLM might have been doing. But as we know, one of the easiest ways to be able to actually evaluate large language model performance, in particular on generative tasks that have to do with English language, is to be able to try them out directly and serve those models in particular. And so this is where serving multiple large language models becomes extremely useful. And what we're going to do is actually serve them with LoRAX. So the first thing I'm going to do is load in a single model version of Llama 2 7 billion. Now, Llama 2 7 billion is going to be the primary model that I'm going to simply attach my fine-tuned adapters onto in order to be able to serve the multiple different fine-tuned model versions that I have. Again, what I've done is fine-tune 3 different models, model version 4830, 4831, and 4832. Each of them has been fine-tuned to a specific customer data set that deals with the domain that customer works in, whether that's orders or payments information and billing and invoices, or account management. And I'm going to be able to serve them all off the same base Llama 2 7 billion model. So the first thing I'll do is try and query with this customer Cashback to the Future. Now, the instruction here is going to be from a customer, show me an invoice, and then they'll have the invoice number that the customer has actually expressed. Now, we can see what the pre-trained version of this model will actually do with this particular query. So I'll just go ahead and print llama 2 7 billion prompted with this exact same instruction. I'm adding in the instruction template that we had from before. And what you can see is, the instruction was to show me the invoice, and llama 2 7 billion has kind of gone a little bit off the wheels. This is the unfine-tuned base model. Has gone off the wheels and said, we're sorry to hear that you want to cancel your order. We will cancel your order and refund your payment. This is not exactly, in line with what I would want for showing me the invoice. And so instead, what I'm going to do is I'm going to try my fine-tuned version of the llama 2 7 billion model that was trained on the actual response for the customer cashback to the future. I'm going to send it the exact same instruction, show me an invoice, and we'll see what it does in this case. Now, what we're doing with this particular command is we're calling llama 2 7 billion, the same base model that I had, and just adding in the adapter from the fine-tuned model version 4830. And you can see that this model does significantly better. It says I'm on it. I'm here to assist you in finding the invoice with the invoice number. So it's learned the templating that we actually use in the context of this customer support automation use case. And it gives the following steps: to access the invoice, log into your account, navigate to billing, and look for the invoice with the invoice number. If you encounter any difficulties or need further assistance, please don't hesitate to let me know. So this is a significantly better response. And actually, if we wanted to, compare to the ground truth or what a similar response had gotten from the training data, you can see that it's in line with, or potentially even better than kind of the initial response that a user had provided in the initial data set. And this query took about 8 seconds to load, including the time to load in that adapter. And I'd say that's roughly on par with what we see for these models overall. Just to show you that this works across different data sets and across different customer profiles, I'll go to the next one, which is the customer license to binge. So here we have, again, a real query from a customer, which says, I can't find the bloody termination charge. I need help. So clearly a frustrated customer. And if we prompt the same unfine-tuned llama 7 billion model, what we'll see is actually probably something very familiar to those of you that have worked with open source models. It just starts to repeat itself. So it says, I'm sorry to hear that. I'll be happy to help you. And then over and over, it says, I'll send you a link to the termination charge page. This is a common, common occurrence that we see when people work with unfine-tuned base open source large language models. And I want to show you a little bit about how fine-tuning can actually help address this. So again, all I'm going to do is take my llama 2 7 billion model, the same one that was the unfine-tuned one, the same one that I was using to be able to query, my previous customer's response, and I'm going to add a different adapter to it, which is going to be the specific adapter for this particular use case, which is the customer license to binge. And what I'm going to do now is execute this query and see how long it takes to be able to load in that new adapter as well as generate the response. In this case, it only takes about 4 seconds. And so here, it seems like a much more reasonable response. I'm here to assist you in finding the termination charge, which is exactly what the customer is asking for. Please provide me with your account details, and I'll be able to check the specific charges associated with the account. And so again, what we see is that by being able to fine tune, we're able to get rid of some of the idiosyncratic behaviors of the unfine-tuned base llama 2 7 billion model. And we're like the repetition, we're able to customize it better to the domain. And what we were able to do this was actually just using the same single llama 2 7 billion deployment model that I had earlier and simply added in the new adapter. And just to essentially round out for good measure, I can show you our final customer, Order Express. Here we have a question about canceling an order with the order number. And again, if I prompt the pre-trained llama 2 7 billion model, what I'll be able to see is, thank you, we're unable to cancel your order. Please cancel again. And some more repetition from llama 2 7 billion model. And now you've probably gotten familiar with it. I'm going to take the same llama 2 7 billion model, simply add in this adapter. This is the same model I've been querying all the way throughout this entire demo. So you've been basically seeing the same base infrastructure. Took about 5 seconds and a lot better response. We understand that you have a question regarding canceling order number, a specific order number. We apologize for any inconvenience. And so this is an easy way for users to be able to really get started with fine-tuning and serving many different fine-tuned model variants all within the same context of the same base model, and therefore the same single GPU that you're paying for in order to be able to serve the individual pre-trained models as well as the fine-tuned models that you have on top. So that's a little bit of what I wanted to show you in terms of how LoRAX works when it's actually being applied to an individual customer domain problem space like customer support. As a refresher, what we did was we connected three different data sets that corresponded to three different customers, all of whom had customer support issues that we standardized: license to binge, order express, and cashback to the future. We were able to train a model version for each of these individual customers, see metrics about it, like its loss curves, as well as its perplexity, understand how long it took to train, with each of these taking under an hour to train on a single T4 GPU. And then finally, we were able to query them directly using LoRAX and on top of the same base Llama 2.7 billion model, and see response times and latencies that were overall quite low. As you want to start to use Predibase, you can actually replicate what I did right here directly through the demo notebook that we've shared earlier. And you can also get started with our playground, where you'll be able to prompt any of the different variants of models that we've already deployed inside of your environment, like Llama 2.7 billion, 13 billion, and 70 billion, as well as your different fine-tuned models directly through our LLM interface. And this will allow you to be able to test out different model versions. And be able to see how well they actually perform on the individual tasks that you're looking to be able to do. Finally, if anyone wants at any point to be able to reach out to us, you can reach out to us through either our customer support channel, or feel free to send us an email as well at support@predibase.com. So this is a little bit of what we wanted to be able to show you with LoRAX, and the ability to go ahead and fine-tune multiple different LLMs to be able to solve a particular task and customize to individual customer data without having to share the data across different deployments, and then be able to serve them highly efficiently. With that, what I'll do is leave up our home screen so you can see a little bit of what it would look like once you sign up for an account and are looking to be able to log in. And I'll turn it over to the rest of our audience that might have any questions.
Awesome. I was actually going to put up this screen real quick, if I can get it. Here we go. We'll jump into the Q&A real quick. So folks, as a reminder, there's a button in the bottom left if you want to try out the platform for free. It's a very small form, and you can fine tune and serve unlimited number of models for 2 weeks, all for free. Super fun to play with. And if you want to learn it, and so there's also a link here for the notebook we covered today. So let's jump into Q&A. A lot of questions, maybe just start with just getting right to the platform, then we'll go and start at the beginning of some of the questions. But one of them that came up multiple times was just about pricing. I know we've shared the pricing link in the chat, but maybe you want to just briefly talk about how we price things on the platform to give folks a little more context.
Definitely. We have two ways that we think about pricing, and it depends on if you want to run in the Predibase AI cloud or if you want to run inside of your own VPC. If you're looking to run inside the Predibase AI cloud, then we predominantly price by consumption. And you can actually see our early access pricing on the Predibase.com pricing website. We have the cheapest way to be able to serve fine-tuned LLMs on the market. Factors cheaper than, for example, serving with OpenAI, a fine-tuned variant there. And so if you're really interested in being able to serve fine-tuned LLMs at scale, please check out our public pricing. And if it looks interesting to you, you can contact us. And we're starting to onboard some early customers. We've already onboarded a handful, and we're onboarding more early customers to that public pricing, with a launch to be able to make it go GA and finalized coming later on. If you want to deploy inside your VPC, we predominantly just price based on the amount of, based on a platform fee to be able to deploy inside your VPC. And then we're looking at being able to price as well based on the amount of consumption of the underlying GPUs that you're using.
Great. And maybe a follow-up question, a couple about the platform. People are asking about, how do we maintain privacy, data access, those things. Maybe we'll talk a little bit about the deployment options, sort of separation of control plane and data plane.
Definitely. So if you go inside of, once you sign up for a Predibase account, and again, you can do this in a free trial, you'll be able to access our documentation. And inside our documentation, you'll actually see an architecture diagram that we have that talks about our deployment model, which aspects of compute and data we may touch, and which aspects, stay particularly and completely closed inside of your environment. One main thing I want to mention is that our VPC deployment model is built for those customers that have high concerns around data privacy and provenance. And so in our VPC model, your data and compute never leave the confines of your private cloud. What we do is we separate out the data plane, which will deploy inside of your virtual private cloud, and our control plane, which will manage our UI and some updates, with the data plane deploying fully inside of your cloud environment. And so data and compute never have to leave the confines of your specific enterprise environment.
Great. And one more quick question about the platform, and then a bunch about fine tuning and that sort of thing. A couple of questions about, do we support different models like Zephyr 7B, different models in Hugging Face? What is our sort of take on how we support open source models?
Yeah, absolutely. So our view is that our model garden, or the set of models that we support, is really kind of the broader community of open source models that exist. So if you want to be able to try out different models off Hugging Face, you can, and it's being able to use it off the path that I suggested, which is to be able to specify the Hugging Face path for the model that you're interested in. We have a set of models that we ran a number of tests and benchmarks against, that we have done the robustness testing against already. Those are some of the variants that you'd be able to see directly deployed inside of our free trial, which include the different variants of Llama 2, for example, Llama 2 7 billion, Llama 2 13 billion, Mistral 7 billion coming soon, as well as a few other models coming soon like Code Llama and Star Code. So those are all different models that we've done and kind of ran rigorous testing against. But if there are any other open source models that you're interested in, you can start to try them out on the platform directly. And I would certainly say, please reach out to us to let us know which open source models you're most interested in. And we'll look to be able to add them into both our testing suite, as well as, if there's enough demand, we can stand up like an instance of it for general users to be able to use in our free trial.
Great. A lot of questions about fine tuning. How many examples do I need? Best practice there. Curious, you guys have fine-tuned a lot of models, right? Or a lot of customers. What do you recommend there?
Yeah, I mean, it's definitely very task dependent. I would say that typically we see people, when they're doing fine tuning, working with about 1,000 to orders of 10,000 examples. Those don't all have to be manually curated, though. Oftentimes it's sufficient to start with a handful of examples and then actually use a strong LLM like Llama 2 70 billion or others to help generate more examples that are similar, to help give the fine-tuned model like more robust examples of different variations of what you're looking for. So it's definitely something that is a bit of a task-specific thing, but it's definitely not something that requires a huge amount of investment in most cases.
Great. So quite a few questions on sort of like data curation, preparing data. So a few questions. So one, any recommendations for how to go about creating training data, as that seems like a pretty challenging task? What are thoughts there?
Yeah, well, I'd say that part of it depends on the type of task that you have and the type of model that you want. So, for something like a code completion model, it can generally suffice just to kind of point your training process at kind of raw chunks of text from your corpus. So for example, just split it by some, word length or something like that and create an example per row. For instruction tuned models where you want to say, do this thing and then have it generate an output, in those cases, you'll want to have like some, more traditional supervised learning examples where you have an input and then an expected output. Sometimes users only have the outputs of what they're looking for, in which case, one technique you can do is you can prompt an LLM to say, given this output, what would be some questions or some things that you might say as instructions to generate it. So that's one way to kind of hack that process. In other cases, you might only have inputs, in which case there are other things that you can do, like giving few shot examples and things like that, to try to get some more quality outputs to work with. So there are different approaches depending on what you're starting with, but in general, there are ways to try to use LLMs, use pre-trained LLMs to make this process a bit simpler.
Got it. And some question about LoRAX and just LoRa and QLoRa. So jump into those. Are the adapters swapped into GPU memory?
Yes. So that's where the exchange term comes from in LoRA Exchange, and this comes back to the multi-tiered cache that I was showing. So basically, any of the adapters that are going to get batched together at once in that continuous batching process that I showed, those all live on GPU at the same time. And in practice, we've done experiments with up to 128 adapters on the GPU at once and have not run into out-of-memory errors. So it's definitely, these adapters are very small as a fraction of the total GPU memory. And the only thing that it affects is, how big your batch size can get, essentially, like how many tokens you can fit in memory at a time. And so if you just throttle that a little bit, then, you should be fine. But what we do is we'll swap the weights off of GPU memory, when we want to move a new adapter onto the GPU. And that's kind of part of this process of making sure that every adapter gets a turn, right? So we're constantly exchanging them in and out in order to ensure liveness of all of the requests that come in.
Got it. And someone had an interesting question about LoRAX. Like, does, obviously make sense for when you have tons of fine-tuned LMs. Does it also make sense, maybe for like one LM that you're serving? Thoughts about that?
Yeah, absolutely. What I would say is that the one case where it would not make sense to use LoRAX is if you only have a single fine-tuned LM and you want to do a dedicated VPC style deployment for it. At that point, it's effectively the same as just doing a normal dedicated deployment. But the nice thing about LoRAX on the Predibase AI cloud is that even if you only have one fine-tuned model, because we're using LoRAX to serve it, in kind of a multi-tenant capacity, it means that you're only having to pay for the tokens that you consume. You're not having to pay for a dedicated deployment. So if you're only using the LM, on occasion, then it's a really, really no-brainer kind of cost advantage to do it that way. But what we often see is that users will start with one dedicated deployment if that's what they're trying to productionize, and over time want to layer on more and more, in which case there's no downside to starting with LoRaX with one adapter. But as soon as you go from 1 to 2, you've already basically halved your cost overhead, right? So it's a huge advantage just from the get-go.
Got it. And while you might be serving hundreds of fine-tuned LMs, if all the models are getting many requests at any given time, how's the memory consumption managed with LoRa?
Yeah, so this kind of comes back to the multi-tier cache concept, is that these adapters, they're pretty small in practice. We've stress tested with hundreds and haven't run into out-of-memory errors yet on an A10G with 24 gigabytes of VRAM. So definitely you can go to quite a large scale. Now in practice, I think 128 adapters on GPU at a time is probably higher than what we would target, because we would rather just scale up more replicas at that point from the perspective of our SaaS environment, because it does start to degrade throughput at some point. So in practice, we find that memory pressure actually doesn't tend to be much of a factor, because we cap how many adapters we're going to put on GPU at a time, and then we just swap in adapters from CPU memory to GPU memory kind of in the background, as different adapter requests come in.
Got it. And someone had a question about, we mentioned briefly the right sizing for the model for the task. That makes intuitive sense. Is there any research on this, or is it just sort of hit and trial experiment? What are your thoughts on right sizing?
Yeah, so the nice thing about LLMs is that because the architectures are pretty well understood and kind of the properties are pretty well understood in terms of how it works, and we're not letting users just kind of give us arbitrary code where we have to execute it to figure out what it does. If someone says, I want to fine tune Llama 7 billion, and they have a particular data set that they want, and then some particular hyperparameters that they want. The nice thing is, because of the declarative abstraction that Ludwig provides, that's really all the information we need to be able to say, okay, how much memory is this going to take, right? And then what type of GPU do we need in order to give the user the highest kind of like performance for their dollar, right? So actually, it turns out to be that the right sizing, we can get that correct pretty precisely, and we do bake in some overhead there just in case we're wrong, right? But we are pretty accurate, I would say, on the right sizing in terms of estimating how much memory we require.
Got it. And Deb, I know you answered this one in chat, but I'll bring it up again. Someone is talking about they setting up new sort of technologies within their sort of VPC or environment can be challenging at times, and so I want to make sure they're picking the right ones. And specifically, it called out like how you might compare Predibase to AWS Bedrock. How is it different and better, given that's another popular solution?
Yeah, absolutely. And one thing to acknowledge is, the space is early still in a lot of the technologies that get developed. And so people are finding that they explore multiple different tools in order to be able to find what's best in class and works for their setup. In terms of the comparison to Bedrock, just sharing what customers that we talk to who have used Bedrock and who may have experimented with Predibase as well really share with us is that it really comes down to a few key differences that I might summarize as interfaces and infrastructure. On the interfaces side, people find what we do in order to be able to bake in the best practices of how to fine tune a model, as well as the right size compute that you need to be able to run in, to be a lot easier way to be able to actually start to fine tune models effectively on your data sets than the interfaces that Bedrock provides. But I actually think one of our key differences is on the infrastructure side. And on infrastructure, what I would say is we've spent a lot of time and effort making sure that you get the most efficient GPU utilization that you're looking for, out of each of the models. That means right-sizing the GPUs so that you can run, for example, a Llama 13 billion model on a single T4. That means you can actually try fine-tuning Llama 2 13 billion inside of our free trial, which is not really something that we see offered in many other platforms at all overall, including Bedrock. And I think that beyond that, we also have the infrastructure benefits on serving brought to you by LoRAX. And so really the focus of this webinar, which is that when you actually start to serve LLMs at scale, you're going to want to be able to serve multiple different variants of fine-tuned models. And you ideally will not want a GPU being spent on each fine-tuned model because that's going to rack up a lot of expense. Instead, with Predibase, you can use the technique via LoRAX and LoRA Exchange in order to be able to actually serve those models in the method that I was showing you earlier today. And I would certainly say that's one of the kind of key differences that we see against a single technology like Bedrock. And the last thing I'll just mention is lock-in. So Bedrock, of course, being an individual AWS service, also only supports a few different large language models in terms of what's supported out of the box. And so what we look at being able to support is kind of the open model garden that we see in Hugging Face. And so if you want to be able to dive deeper into any part of this comparison, or just work directly with us to understand a little bit of, is it worth the time and investment to be able to onboard a platform like Predibase, we're confident we can make it a relatively low barrier to entry. Please do either check us out in the free trial or reach out to us and we can get started quickly.
Great. Couple small rapid fire questions. I've seen a few around sort of the compliance related and how data is stored. I know we touched about it briefly earlier, but maybe Travis, you just want to speak to that real quick.
Yeah, I mean, I think the most important thing to emphasize there is that for folks who are running in kind of regulated environments, or where privacy, security, provenance is particularly important from a compliance standpoint, that's one of the main motivations for our VPC deployment that we have. So we can run all the data planes, so everything that touches or interacts with the data entirely in your environment. No data ever leaves that environment. We also don't store any data that's used for training models. So we just read it in privately in your environment into the compute that's running in your private environment, train the model, write those model artifacts out again to a bucket that lives inside your VPC, and then completely discard the data. So nothing ever goes over to our servers. No Predibase employee can possibly do anything, that you wouldn't want them to do with that data.
Great. And I know we touched on this in the presentation, but maybe one more quick question because it's come up a few times. Do we support QLoRA? Is it configurable and all that?
Yeah, absolutely. So we're really big fans of quantization. So all of the models that you can use with LoRAX, you can train the model either with or without quantization. It actually doesn't make a difference in practice because even in QLoRA, the weights of the fine-tuned adapter weights are in FP16, not in quantized form. So we do use 4-bit quantization, so 4-bit QLoRA by default, and that can be configured. You can use 8-bit quantization, which is a little bit faster in terms of throughput, but obviously twice as much memory overhead, or you can actually disable quantization entirely and train in FP16.
Awesome. I know we're at time is just about up, so I want to thank everybody for joining us today. Thank you for our presenters for the thorough talk. Really engaged audience, love all the questions. If we didn't get to your question, please shoot us a note. We have a contact us form on our website. And a reminder, if you do want to test out Predibase, start fine-tuning a bunch of models and serving them for free for 2 weeks, there's a short form and a button in the bottom of the screen. The recording will be shared after, and everyone have a great rest of your day. Thank you.
Thanks, everyone.
Thank you, everyone.